To solve a problem that's related to interest, we first need to know which formula for compound interest do we use. We have two that we learned in class. One is A equals P 1 plus R over N to the power of NT. This is used for interest that is compounded quarterly, monthly, semi-annually, annually, daily, and so on and so forth. The other equation that we have is A equals PE to the RT. And this is for interest that is compounded continuously. So you go through your question and you look for the word compounded. And if the word continuously comes after compounded, then we know that we have to use A equals PE to the RT. If you see anything other than compounded continuously, then you'd use the first equation. So A equals the total amount in the end. P equals the starting amount, which in this case we start with $25,000. E is just the number 2.71828. It's just a number like pi. R is the interest rate, which in this case is 5.4%, so we're going to change that to 0.054, and T is the time. So the question is asking us how long. So that means that T is unknown. So I must know what A is, otherwise I won't be able to solve the problem. So it doesn't give me a number, but it does give me a keyword, which is that the amount doubles. So I know that I'm going to have to end up with double or 2 times as much money as I started, which is 2 times 25,000 or $50,000. So now I can solve the problem. I'll give myself some more space over here. So I'm going to plug in those values for A, P, E, R, and solve for T. So I'm trying to end with 50,000. I start with 25,000. E is just a number. R is the value 0.054, the interest rate. And T is how much time. So I'm trying to solve for something that's an exponent. So to get a T out of the exponent, I'm going to have to take logs on both sides. But I don't want to do that right now because I've got this 25,000 in the front. And it's not being raised to the power of T. So I need to get that over on the other side first by doing the opposite of the multiplication and dividing it over to the left side. And what I end up with is that 2 is 2.718, or E. You can write the number E if you like, to the power of 0.054 T. Okay, and that 2 represents that the money is doubling. So in order to get the T to come down, I'm going to do logs on both sides. And if you want, you can do natural log, because that's a really natural choice when you have base E. So 2.71828 all to the power of 0.054 T. So now I can use law number 3 to take the exponent and make it a coefficient. I get log of 2 is 0.054 T times log of E, or log of 2.71828, so on and so forth forever. So to solve for t, I can just divide by all those things. Divide by 0.054, leave the t there, divide by log of e. So on the left side, I'm going to divide by 0.054 log of e. So now I need my calculator. Turn it on. I'll go log 2 divided by 0.054 log, and I'll actually write the letter E using yellow divided sign. And I get a time of 12.84 years. So altogether, it takes 13 years. So don't forget to write your answer as a full sentence. It takes 13 years for the money to double. Okay, so to check your answer, you can plug this back into the calculator. We can plug this into the original equation, the P e to the RT. So I start with an amount of money that is $25,000. I multiply it by e to the power of the interest rate times the time, which is 12.83. And the more decimals I keep, the closer my answer will be to the right answer. Does that equal 50,000? Well, $49,999.84 is pretty close to $50,000. So I'm pretty sure I got the answer right.